Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 1 in a session May-June 2021 Paper 1-1. So let's start with the first question. Question number 1. The equation of curve is such that its second derivative is given. It is given that the curve passes through the point 1 by 2, 4. Find the equation of curve. Okay, so the first derivative we have dy over dx is equals to 3x power minus 4 plus 32x cube. Okay, to find the equation of curve we have to integrate on both sides dy over dx with respect to dx, and 3 is outside, integration of x power minus 4 dx plus 32 is outside, integration of x cube dx. Right. Okay, now dx is cancelled with dx derivative and integral is cancelled. We are left with y equals to 3 x power minus 4 plus 1 over minus 4 plus 1 plus 32 x power 3 plus 1 over 3 plus 1 plus some constant of integration. Right. Okay, further simplification, we have y equals to 3 x power minus 3 over minus 3 plus 32 x power 4 over 4 plus c. Right. Okay, let me simplify this further. We have y would be equals to minus 1 over x cube, and 32 divides 4. 4 times 8 is 32, so 8 x power 4 plus c. Okay, to solve for the constant of integration we have to use the condition, the point 1 by 2 and 4. Okay, let me solve x equals to 1 by 2 and y value equals to 4. So we have 4 equals to minus 1 over 1 by 2 whole cube plus 8 1 by 2 power 4 plus the constant of integration. Right, now let me simplify this. We have 1 by 2 and its whole power is 3 minus 1 divides answer is negative 8, so 4 equals to negative 8, and we have 1 by 2 power 4 times by 8 is 1 by 2 plus 1 by 2 plus some c. Okay, to solve for c we have to say 4 plus 8 minus 1 by 2. This is the c value. Okay, 4 plus 8 minus 1 by 2. This is 23 by 2 is the c value. Now we have the equation of curve is just substitute over here. Y would be equals to minus 1 over x cube plus 8x power 4 plus 23 over 2. This is equation of curve. Question number 2. The sum of first 20 terms of an arithmetic progression is 405. This is S20. And the sum of first 40 terms is 1410. This is S40. Right. Find the 60th term of the progression. This is an arithmetic progression. Right. So we have the formula Sn equals to n by 2 into 2a plus n minus 1 into d. Right, so let me solve for S20 first. So S20 we have given is 405. This is equals to 20 by 2 2a plus n minus 1 into d. Right, so this is not n plus 1, n minus 1, 19 times d. Right, 405 equals to 10 into 2a plus 19d. Right, so 405 divided by 10, we have 405 over 10 is 81 by 2. So we can say that 81 over 2, this is 2a plus 19d. This is my first equation. Right, now the second is we have given as 40. So let me solve for the second equation. As 40 is 1410 which is equals to 40 over 2 into 2a plus 40 minus 1 is 39d, right? 1410, this is equals to 20 into 2a plus 39d. Okay, and we have 1410 divides 20, which is 141 over 2. 141 over 2, this is equals to 2a plus 39d. This is my second equation, right? Now solving the two system of equations, we can get the values of a and d, and we can easily find the 60th term of the progression, right? Okay, so let me subtract equation 1 and equation 2. We will get the d value, right? We have 2a plus 19d, which is equals to 81 by 2. And the other equation is 2a plus 39d is equals to 141 over 2, right? So when we subtract, we have to change the signs. Okay, so we have negative, negative, and negative over here. Plus 2a and minus 2a is cancelled. 19 minus 39 minus 20 times d. This is equals to, we have 81 divides 2 minus 141 divides 2 minus 30, right? Okay, minus 30 divides minus 20, which is 3 by 2. So the d value is 3 by 2. Okay, and what is 3 by 2 in decimals, which is 1.5. So we have the d value. Let me substitute that d value into first or second equation to get the a. So put d in equation 1. We can solve for a. So we have 2a equals to 81 over 2 minus 19 times d, which is 1.5, right? Let me simplify this further. We have 19 times minus 1.5 and add 81 by 2, which is 12 divided by 2, so a value is 6. Now we have a and d. Just solve for the 60th term of the progression. So the 60th term is an equals to a plus n minus 1 into d. So a 60, a is 6 plus 60 minus 1, and d is 1.5. So a 60, this would be equals to 6 plus 59 times 1.5. Okay, 59 times 1.5 and add 6. So this would be equals to 94.5. The 60th term is 94.5. Right. Question number 3, part A. Find the first 3 terms in the expansion of this in ascending powers of x. Okay, so first 3 terms we need to find. Okay, 3 minus 2x whole power is 5. The first term is 3 power 5 plus 5c1, 3 power is 4 minus 2x power is 1. The third term is 5c2, 3 power is 3 and minus 2x power is 2, right? Further simplification, 3 power 5 is 243 plus 5c1 is 5 times 3 power 4, 81 times minus 2x plus 5c2, which is 10, 3 cube is 27, minus 2 square is 4, x square. So this is 243 minus 5 times 81 times 2, which is 810 x, and 10 times 27 times 4, which is 1080 x square. These are the first three terms in the ascending powers of x, right? Now moving to part B, hence find the coefficient of x square in the expansion of this, right? So let me expand this term. So 4 plus x whole square and its product with 3 minus 2x power 5, right? So we have 4 square plus 2a and b plus x square. This is expansion for the first term times this one, 243 minus 810x and plus 1080x square, right? 4 square is 16, 2 times 4 is 8x plus x square. This product with 243 minus 810x plus 1080x square, right? Let me simplify this further. We have to find the coefficient of x square. 16 times this is constant, 16 times this would be x, 16 times this would be x square. So 16 times 1080 x square. This is x square term, this is x term, this is x square term, plus 8x times minus 810x. This would be x cube. This is x square plus x square times 243. This would be x cube term, this would be x power 4 term, right? Okay, so we have 1080 times of 16 is 17280 x square, and 8 times minus 810, which is minus 6480 minus 6480 x square, and the last is plus 243 x square. Okay, now let me simplify the coefficients. So we have 17280 minus 6480 plus 243, 11043 x cube, x square, sorry, not x cube, this is x square. So we can say that coefficient of x square is 11043, right? Question number 4. The diagram shows the part of the graph of y equals to a tan x minus b plus c. Given that the b values lies between 0 to pi, state the values of the constants a, b and c. Okay, so if we observe the graph of the tangent function, the base function tan x, and we have this point. Okay, and for the base function the point would be origin 0 0, and this point moves to 1 by pi by 4 and 1. Okay, so we can say that the base function is tan x, and it replaces to a tan x minus b plus c, right? So we have a point 0 0 changes to pi by 4 and 1. Okay, so pi by 4, what is pi by 4? Pi by 4 is horizontal translation, right? So what is horizontal translation over here? So b value is the horizontal translation, right? This implies b is pi by 4 horizontal translation, right? And what is 1? 1 0 changes to 1. 1 is the vertical translation. The c value is the vertical translation. So c value we have is 1, which is the vertical translation. Right. Let me take another point to get the a value. So if we can take this point pi by 2 and 3, right, we can easily get the a value, right? So we have y would be equals to a tan x minus the b value is pi by 4 plus the c value, which is 1. right? And we have the point pi by 2 and 3, right? So pi by 2 and 3, substituting this point, we can easily get the a value. So y value is 3, a tan pi by 2 minus pi by 4 plus 1, right? Let me simplify. We have 1 by 2 minus 1 by 4, which is pi by 4, right? And in radians, tangent pi by 4 is 1. Tangent pi by 4 is just 1. So we have 3 would be equals to a plus 1. So to get the a value, we can do 3 minus 1, which is equals to 2. This is the a value, right? So here we can say y would be equals to 2 times of tangent x minus pi by 4 plus 1. So a is 2, b is pi by 4, and c value is 1. Question number 5. The 5th, 6th and 7th term of a geometric progression are 8k, minus 12 and 2k respectively. Given that k is negative, find the sum to infinity of the progression. We have to find s infinity. Okay, so we have given a5, which is equals to a r power 4. This is 8k. We have a6, which is a r power 5. This is minus 12. And a7, which is a r power 6, which is equals to 2k. Right. We have given that k value should be negative, and we have to find sum to infinity. So what is s infinity? Which is a over 1 minus r. So we have to find the a, the first term, and the common ratio. But before doing this, we have to solve for the k value, right? So if we use the formula for the common ratio r, we know that r is second term over first term, or third term over second term, or fourth over third, or fifth term over fourth term, or we can say a6 over a5, or a7 over a6. So here we have given the 5th, 6th and 7th term. So we have to use this combination to get the k value, right? Okay, so we can say that a6 is minus 12 over a5 is 8k. This would be equals to a7 over a6. a7 over a6, which is 2k over negative 12, right? Now let me simplify. So 12 times 12 is 144. Negative times negative is positive. 2 times 8 is 16. K times k is k square, right? So 144 over 16. This is 9k square. 9 is the k square value, and we can say that k would be equals to plus minus square root of 9, which is equals to plus minus 3. And we have given this, given that k should be negative, so we can say k is equals to negative 3. Yeah, this is given to us, right? Okay, so when k is negative 3, what are the three terms we have? So here we have a5 is 8 times negative 3, a6 is negative 12, and a7 is 2 times k value, which is negative 3, right? So we have 8 times 3 is 24. So minus 24, minus 12, and minus 6. These are the three terms, right? Okay, now let me solve for r, the common ratio. So what is r? R is a6 over a5, minus 12 over minus 24, which is 1 by 2, right? So we got the r value, which is 1 by 2, right? Now let me solve for a. So if I use this information, a5 is a r power 4, right? So a5 is given, which is negative 24. A we have to solve. R is 1 by 2, its power is 4, right? Now let me solve for a. 24 divides 0.5 power 4, or 1 by 2 power 4. This is the a value, right? 0.5, its power is 4, and minus 24 divides answer. Minus 384 is the A value. 384 with a negative sign is the A value. Right. Now the next step is just to find the sum to infinity. Now let me do this here. So we have the formula for sum to infinity. S infinity is A over 1 minus R. So what is S infinity? A is minus 384 over 1 minus R is 0.5. Let me simplify this. 1 minus 0.5, which is 1 by 2, and minus 384 divides answer, which is equals to negative 768. This is sum to infinity of the geometric progression. Question number 6, the equation of curve is y equals to this, where k is a constant, the line is tangent to the curve, find the value of k. Okay, so the line is tangent to the curve, it means it touched the curve at exactly one point, right? So first we need to find the point of intersection of the curve and the line, and when it touch at one point, it means the discriminant should be equals to 0. Right, so point of intersection, we can say 2k minus 3 into x square minus kx minus k minus 2. This would be equals to 3x minus 4. The line and the curve, the point of intersection. Now let me simplify this. 2k minus 3 into x square minus kx minus 3x minus k plus 2 and plus 4, shifting 4 over here, and this would be plus 4. This would be equals to 0, right? So 2k minus 3 is the coefficient of x square minus k plus 3 is the coefficient of x, and we have 6 minus k is a constant term, right? So if it is tangent, so it means the discriminant should be equals to b square minus 4ac. This should be equals to 0. It touched the curve at exactly one point, right? Okay, so what is the b value? B value is negative k negative 3 its whole square minus 4 times the a value is 2k plus minus 3, and the c value is 6 minus k. This would be equals to 0. Let me open this. We have k square, and 2 times 3 would be plus 6k. 3 square is 9, minus 4 is outside. 2 times 6 is 12k. 2 times minus k is 2k, is minus 2k square, minus 3 times 6 is 18, plus 3k. This is equals to 0. K square plus 6k plus 9, minus 4 is outside, minus 2k square, 12 plus 3 is 15k, minus 18. This would be equals to 0. So we have k square plus 6k plus 9 plus 4 times 2 is 8k square. 4 times 15 is minus 4 times 15 is minus 60k, and minus 4 times minus 18 is positive of 72. This would be equals to 0. So we have 9k square, 6 minus 60, 54 minus 54k, and the constant term is 72 plus 9, 81. This would be equals to 0, right? We can divide throughout the equation by 9. We have k square, 54 divides 9 is minus 6k, and 81 divides 9 is 9 plus 9. This would be equals to 0. Now let me factorize this. We have 3 times 3 is 9. So k square minus 2 times k times 3 and plus 3 square. I just opened the formula for a minus b whole square. Okay, so here we have k minus 3 whole square equals to 0, right? So taking square roots on both sides, we have k minus 3 equals to 0 and k value would be equals to 3. We have to solve for k, which is equals to 3. Question number 7, part A, prove the identity. Left hand side should be equals to the right hand side. So as you can see, we know that cos 2 theta is 1 minus 2 sine square theta, right? Cos 2 theta is also equals to 2 cos square theta minus 1, or we can say that it is also equals to cos square theta minus sine square theta, right? And we have another identity, cos square theta plus sine square theta. This would be equals to 1. And we have cos square theta, this would be equals to 1 minus sine square theta. So in the denominator we can use 1 minus sine square theta as cos square theta, right? And in the numerator, and we have to make 1 minus tan square. So which identity we have to use? This, it should be equals to this or this one we have to use. Okay, so let me take left hand side, right? And we can say that 1 minus 2 sine square theta over 1 minus sine square theta. This would be equals to 1 minus 2 sine square theta can be equals to this or this, but we have to use this one because we have to make 1 minus tan square, right? So we can say this is equals to cos square theta minus sine square theta divides cos square theta. Okay, now let me split the numerator. So this is cos square over cos square minus sine over cos. Sine square theta over cos square theta. So cos over cos is just 1, sine over cos is tangent, tan square theta. This is equals to my right hand side. Hence proved. Now for part B, hence solve this equation would be equals to 2 tan power 4 theta, for theta is between 0 to 180 degree. So this whole thing is equals to 1 minus tan square theta, put it equals to 2 tan power 4 theta, right? So if I simplify this, we have 2 tan 4 theta plus tan square theta minus 1, this would be equals to 0, right? Okay, now we have to factorize this. We have to make the factors. 1 times 2 is 2 and 2 minus 1 is would be 10, right? So 2 tan 4 theta plus 2 tan square theta minus tan square theta minus 1, this would be equals to 0. Taking 2 tan square theta common, we are left with tan square theta plus 1. Taking minus 1 common, we are left with tan square theta plus 1, right? So the two factors are tan square theta plus 1 and 2 tan square theta minus 1. This would be equals to 0, right? Now let me put both factors separately equals to 0 to get the value for tan. So tan square theta would be equals to negative 1, and here 2 tan square theta is equals to positive 1, right? And if we do tan square theta, taking square roots, so tan theta would be equals to square root of negative 1, which is iota. And here we can say tan theta is 1 over square root of 2, right? So tan theta, this would be equals to iota. So we have a complex 1. This is a complex root, so we are not solving the complex one because theta lies between, the range of theta is between 0 to 180. So we have to get the root from the second root. Okay, second factor. So we can say that tan theta is equals to plus minus 1 over square root of 2. So when we are scaling, we do plus minus by taking square roots, right? Okay. So we can say that tan theta is 1 over square root of 2, or tan theta is minus 1 over square root of 2. Let me solve for theta first. So theta would be equals to tangent inverse of 1 over square root of 2 with a positive 1, and again here we are solving for positive, and then we can check tangent is negative in which quadrant, right? Okay, so we can, the domain is in degrees, so let me convert my calculator into degrees. So tangent inverse of 1 divides square root of 2, sorry, this square root of 2, this would be equals to 35.26, 35.3 we can say. Theta is equals to 35.3 degrees. Okay, so by using the cast rule, we know that tangent is positive in first and third quadrant, but third quadrant does not belongs to our domain. If we do third quadrant, this is 180 degree plus the answer, which is 215, which is not belongs to the domain, right? Okay, so it has the same value, and tangent is negative in second and fourth quadrant. So we can do the value for the second quadrant. Second quadrant is 180 degree minus 35.3, which is equals to 144.7 degrees. So these are the two values of theta that belongs to the domain between 0 to 180 degree. Question number 8. The diagram shows a symmetrical metal plate. The plate is made by removing two identical pieces from a circular disc with center C. So these are the two identical pieces from a circular disc of center C. The boundaries of the plate consist of two arcs PS and QR of the original circle and two semicircles with PQ and RS as a diameter, right? So these are the diameters of the semicircle. PQ is the diameter and RS is the diameter of the two semicircles, right? Okay, now the next part, it says the radius of the circle with the center C is 4 centimeter, right? So from center C to any point on the circumference of that circle, this is 4 centimeter, and PQ and RS is also 4 centimeter. This side is 4, this side is 4, and if we connect, this is 4, this is also 4 and 4, right? If we do this side, this is CS is 4, CR is 4, because the radius is given, we have is 4, right? So if these are 4, so it is if we consider the triangle PQC or RSC, all the three sides are same, so this is an equilateral triangle. All the three angles should be equals to 60 degree, and 60 degree in terms of radians is pi by 3. Yes, pi by 3, 60 degree. So means all the angles are pi by 3. The three sides are same, the three angles are same. Okay, part A show that the angle PCS is 2 pi over 3 radians. PCS. This angle we have to solve. Okay. This is also equals to pi by 3. Pi by 3 and pi by 3. Since we have given that the metal plate is symmetrical, so this, if this angle and these two angles are same, then these two angles are also same, and the whole circle is equals to 2 pi, right? So we can say that 2 pi is the whole circle, right? So from 2 pi we have to subtract this pi by 3 and this pi by 3. Pi by 3 and minus pi by 3, we will get these two angles, and they are symmetrical. We have to divide by 2 at the end. Okay, so we can say 2 pi minus pi by 3 minus pi by 3, which is 4 pi by 3. So these two are 4 pi by 3 when you add them up. So since it is symmetrical, so we have to do 4 pi by 3 divided by 2 divided by 2. This would be equals to 2 pi by 3. This is PCS. The angle PCS we can say is 2 pi by 3. 2 pi over 3, and this is also 2 pi over 3. And the sum of 2 pi by 3, pi by 3, 2 pi by 3, and pi by 3 is equals to 2 pi, the circumference of a circle. Now moving to part B, find the exact parameter of the plate. Okay, so the exact parameter of the plate, we can say the parameter is basically the sum of the two arcs, as you can see, PS and QR, and these two semicircles, P to Q and R to S, right? So the arc, we have PS and QR. These are the two identical arcs, and the arc lengths we have to find, and the semicircles we have PQ and RS. Okay, so first let me find the arc length. Arc length PS or QR, which is equals to radius times theta. So we have the radius, which is equals to 4, and theta we have given is 2 pi by 3. So this is 8 pi by 3, right? So this is 8 pi by 3, this would be 8 pi by 3. Now let me find PQ, the semicircle. Semicircles circumference. Circumference of a circle is 2 pi r, and for half of a circle is dividing by 2. So this is pi times radius. Okay, so we have pi times r. We know that the diameter of the circle PQ and RS is 4 centimeters, so the radius would be equals to 2, so 2 pi. So we can say Q is 2 pi and RS is also 2 pi. So now let me solve for the parameter. Sum of all sides, which is equals to 8 pi by 3, the arc length, plus 8 pi by 3, the arc length, and semicircle. Circumference of a semicircle is 2 pi, plus the other is 2 pi. Right. Now let me simplify. We have 8 by 3 plus 8 by 3 plus 2 plus 2, which is 28 by 3 pi. This is the exact parameter of the metal plate. Now for part C, show that the area of the plate is 20 over 3 pi plus 8 square root of 3 centimeter square. Okay. So if we look at the plate again, we have to find the area. So if I can consider the two sectors, area of two sectors, PCS and QCR, the two area of a sector, which is equals to half radius square theta. Area of sector of a circle is half radius square theta. So we have half, the radius of the circle is 4, so we do 4 square, and theta we have 2 pi by 3. Okay, so 2 is cancelled with 2, 4 square is 16 over 3 pi. Okay, so area of a sector, we can say that area of sector PCS and QCR, this is equals to 16 pi over 3, right? So we can say this sector is 16 pi by 3, this is 16 pi by 3. Now we have to find the area of this triangle and subtracting the area of a semicircle, because semicircle does not include in the triangle, right? So we can say area of triangle P, C and Q, this is half, the two sides are 4, and sine of angle between them, which is pi by 3. Half the two sides and sine of angle between them, right? So now let me calculate in radians. We can do in radians. Number 2, sine pi by 3, which is square root of 3 by 2 times by 4 times by 4 divided by 2, which is 4 square root of 3. right? So area of a triangle, and we have to subtract the area of a semicircle. Area of semicircle. Area of a circle we have given is pi r square, and area of a semicircle is pi r square divided by 2. So pi by 2, radius is 2 square, so we have 2 pi, right? Okay, now to find, you have to do area of a triangle minus the semicircle, right? So from here, area of triangle minus area of semicircle, right? So this would be equals to 4 square root of 3 minus 2 pi, right? So we can say that the area of this sector PCS and QCR, this is 16 pi by 3, 16 pi by 3 plus 16 pi by 3, and this area is area of a triangle minus area of a semicircle, which is equals to 4 pi by 3 minus 2 pi, and times by 2 because we have another circle, semicircle and a triangle, right? So we can find the exact area. So we can say that area would be equals to 16 pi by 3, the first sector, plus 16 pi by 3, the second sector, plus 2 times of 4 square root of 3 minus 2 pi. I hope this is clear now. 16 plus 16, which is 16 plus 16, which is 32 pi by 3. This is 32 over 3 pi, plus 2 times 4 is 8 pi by 3 minus 4 pi, right? So 32 by 3 and minus 4, which is 20 pi by 3, 20 pi over 3 plus 8 pi centimeter square. So we have shown that the area of the plate is 20 over 3 pi plus 8 square root of 3 centimeter square. Question number 9. Functions f and g are defined as follow: f of x and g of x, where a is constant. Part A, state the range of f. So the domain of f, we have given the x values that are greater than equals to 2. So what is the function value at 2 and what is a function value at infinity? 2 and more than 2, right? So we can check 2 minus 2 whole square minus 4, which is 0 whole square minus 4, which is equals to minus 4, right? And for infinity, we can do infinity minus 2 whole square minus 4. So we have infinity minus 2 is infinity, infinity square minus 4. This would be equals to infinity, right? So all the values that are greater than equals to negative 4. So we can say that the range of f of x is greater than equals to negative 4 and more than negative 4, right? Now for part B, find f inverse of x. So f of x we have given is y equals to x minus 2 whole square minus 4. Right, now we need to switch the variables. We can say x would be equals to y minus 2 whole square minus 4, and next step we have to solve for y. So x plus 4, this would be equals to y minus 2 whole square, right? So we can say that y minus 2, this would be equals to plus minus square root of x plus 4, right? So from here we y is equals to 2 plus minus square root of x plus 4. So now we have to take positive square root or negative square root depending on the domain. So we know that the domain of f of x is the range of f inverse of x, and the domain of f inverse of x is the range of f of x, right? So the answer, the domain of f inverse, domain of f inverse is equals to the range of f. The range of f we have given is greater than equals to negative 4, right? So this should be greater than equals to negative 4. Okay, so when it is greater than equals to negative 4. Okay, when I put equals to -4, so -4 and +4, this would be equals to 0, and we have 2, so we got the range which is greater than equals to 2. Now greater than equals to 2, so we have done with 2. Now the next would be 3. So if I put greater than -4 is -3, -3 plus 4 is 1, and square root of 1 is 1. So if we do 2 plus 1 and 2 minus 1, so we have to 2 plus 1 makes 3 and 2 minus 1 makes 1, so we have to do with a positive 1. Yes, so f inverse of x, this is 2 plus square root of x plus 4, because it satisfies the domain and range. Now for part C, given that a value is -5/3, solve the equation f of x would be equals to g of x. So f of x we have given is x minus 2 whole square minus 4. This would be equals to g of x, ax plus 2. A value is -5/3x plus 2. Right. Now let me solve for x. Okay, open the square. We have x square plus 4 minus 2ab, 2x minus 4 plus 5/3x minus 2. This would be equals to 0. Plus 4 and minus 4 is cancel out. We are left with x square. And what is 5/3 minus 4? 5/3 minus 4 is -7/3x and -2. This would be equals to 0. Right. Now let me solve this by using factorization, or okay, multiplying by 3. 3x square minus 7x and minus 6, this would be equals to 0. Right, so multiplying by 3 throughout the equation, 3 minus 7 and 3 times 2 makes 6. Let me factorize this. Okay, so we have 3 times -6 is -18, and 9 times -2 is -18, and 2 minus 9 is -7. 3x square plus 2x minus 9x minus 6 equals to 0. And let me take x common. We have 3x plus 2, -3 common, 3x plus 2. This would be equals to 0. The factors are 3x plus 2 and x minus 3. This would be equals to 0. So from here we have x would be equals to -2/3 and x would be equals to 3. Right, so which one we have to consider, -2/3 or +3? We have to solve the equation when f of x would be equals to g of x. So we have given that the domain of g of x is all real numbers, but f of x value should be greater than equals to 2 or more than 2. So 3 is okay, but this is the negative one. Right, so we can say that only solution is x equals to 3. Right. Now for part D, given instead that G composition f inverse of 12 is 62, find the possible values of A. Right, so what is f inverse of 12? F inverse of 12, f inverse of x is 2 plus square root of x plus 4, which is 12 plus 4. Right, let me solve. What is 12 plus 4, which is 16, and square root of 16 is 4, and then plus 2 would makes 6. This is equals to 6. Right, so from here g f inverse of 12, this would be equals to g of 6. Right, f inverse of 12 is 6. What is g of 6? Okay, g of 6, g of x is ax plus 2. Right, so g of 6 would be 6a plus 2. Right, and g of 6a plus 2 would be a times x, a times 6a plus 2, and then plus 2. So this is 6a square plus 2a plus 2. Right, okay, so and we have to put this equals to 62 and find the possible values of a. Now let's do this. 6a square plus 2a plus 2 minus 62, this would be equals to 0. 6a square plus 2a minus 60, this would be equals to 0. Right, so let me divide by 3. So dividing by 2, Yes. 2 times 3 is 6. 2 times 1 is 2. 2 times 3 is 6 and 0. Right. Now we have a quadratic equation, so factorize it. Okay, so we have 3 times minus 30. This is negative 90. And we can say 10 times 9 times 10 is 90, and 10 minus 9 is 1. So 3a square plus 10a minus 9a minus 30, this is equals to 0. Taking a common, we are left with 3a plus 10, and taking minus 3 common, 3 times 3 is 9, and plus 10. Okay, so the two factors are 3a plus 10 and a minus 3. This would be equals to 0. So from here the two possible values of a are 3a plus 10 would be equals to 0, and a minus 3 is equals to 0, right? So from here we can say a would be equals to minus 10 over 3, and the other one is a is equals to 3. So these are the two possible values of a. Question number 10. The equation of a circle is x square plus y square minus 4x plus 6y minus 77 equals to 0. Part A. Find the x coordinates of the points A and B where the circle intersect the x-axis. Okay, so when the circle intersect the x-axis, it means the y coordinate would be equals to 0. Right, so y would be equals to 0. So let me substitute y equals to 0 in the equation of circle. We have x square minus 4x minus 77. This would be equals to 0, right? Now let me factorize this. 1 times 77 is 77, and 7 times 11 is 77. So x square plus 7x minus 11x minus 77, this would be equals to 0. X is common, we are left with x plus 7. Minus 11 is common, we have x plus 7. This is equals to 0. So x minus 11 and x plus 7 are the two factors equals to 0. So from here the x coordinates of points A and B are x is equals to 11 or x is equals to negative 7, right? Now for part B, find the point of intersection of tangents to the circle at A and B. So tangents to the circle at A and B. The equation of circle we have given is x square minus 4x plus y square plus 6y minus 77. This would be equals to 0, right? Now let me find the center and radius of a circle. So we can say x square minus 2a and b plus 2 square plus y square plus 2y times 3 and plus 3 square makes 6. This would be equals to 77, plus 2 square is 4, plus 3 square is 9, right? This is x minus 2 whole square plus y plus 3 whole square equals to, we have 77 plus 4 plus 9, which is 90, equals to 90, right? So we can say that the center of a circle is equals to 2 and negative 3, and the radius of a circle is square root of 90, right? So we need to find the point of intersection of tangents to the circle at A and B. So first we need to find the equation of tangent to the circle at point A and at point B, and then there we need to find their point of intersection. To explain this, let me consider this circle, and it has a center which is C, which is 2 minus 3, and we have to find the equation of tangent at point A. Let's say the x coordinate of A is 11 and the y coordinate is 0, right? So we have to, this is a tangent to the circle if I draw this line. So we need to find the equation of tangent to the circle. As we know that tangent is always perpendicular to the radius or the diameter of a circle, right? It is perpendicular. So let me find the slope and then the negative reciprocal, right? So we can say that the slope of AC, this is y2 minus y1, which is A and C, minus 3 minus 0 over x2 minus x1, which is negative 3 over from 11 take away 2, which is equals to 9, negative 9, which is 1 by 3. So 1 by 3 is the slope of AC, and the slope of this line is, slope of a line which is perpendicular to AC is negative reciprocal, which is negative of 3, right? Okay, so now we need to find the C value as well, right? Now the equation of tangent is equation of tangent to the circle at A. This would be equals to y equals to mx plus c, right? So if I consider this as y equals to mx plus c, so y equals to m value is negative 3x plus c, and to get the c value we have to use the a coordinates of A, right? The coordinates of A are 11 and 0. Y is 0 minus 3 times 11 plus c, and from here the c value is positive of 33, right? So the equation of tangent at A is y equals to minus 3x plus 33, right? Now the second equation we have to find the equation of tangent to the circle at point B by doing the same steps. Again, we need to consider the circle with the center, the same center C, which is 2, negative 3, and the point B, and the B point x coordinate is negative 7 and the y coordinate is 0, right? We need to find the equation of tangent to the circle at point B. This equation we have to find, and we know that the tangent is perpendicular. Equation of tangent is perpendicular to the radius or diameter of a circle. So same steps, we need to find the slope of BC. 0 plus 3 over minus 7 minus 2, which is equals to 3 over minus 9, which is minus 1 by 3, right? And the slope of a perpendicular BC, this line, this is negative reciprocal, which is equals to 3, right? Now we need to find the equation of tangent at B. Yes, equation of tangent at B. Right. So the equation of tangent to the circle at B is y equals to 3x plus c, and to get the c value using the point 0 would be equals to 3 times minus 7 plus c. So here c value is 3 times 7 is 21, so shifting over here would be positive of 21, right? So we have tangent at B is y equals to 3x plus 21, right? So these are the two equation of tangents to the circle at point A and at point B. Now we need to find the point of intersection of tangents at A and B. So for point of intersection, we need to put both of them equal. So we can say minus 3x plus 33, this would be equals to 3x plus 21. Minus 3x minus 3x x, this would be equals to 21 minus 33, right? Minus 3 minus 3 is minus 6x, this would be equals to 21, take away 33, minus 12. Minus 12 divides minus 6, this is 2, so x would be equals to 2. Now let me find the y coordinate for the point of intersection by substituting x into the equation of first tangent or the second tangent. So y would be equals to minus 3 times 2 plus 33, minus 6 plus 33. So from 33 we need to take away 6, which is 27. So we can say that the point of intersection of tangents to the circle at point A and at point B are xy, which is equals to 2 and 27. This is the point of intersection of two tangents. Question number 11, the equation of curve is given. Part A, find the equation of normal to the curve at the point 4, 4, giving your answer in the form of y equals to mx plus c. So for equation of normal, we have to find the gradient first. So dy over dx, which is equals to 2. The power rule, we have to do the power, the base function, power minus 1, the derivative of base function, which is 3, and the derivative of x is just minus x is minus 1. So 2 is cancelled with 2. So we have 3 over square root of 3x plus 4 and minus 1. Right. Now let me find dy over dx at x is equals to 4. Right. 3 over square root of 3 times 4 plus 4 and minus 1. 3 times 4, we have 12 plus 4, 16. Square root of 16 is 4. So we have 3 by 4 minus 1 is minus 1 by 4. This is the gradient of tangent or gradient of the curve. The gradient of normal is negative reciprocal, right? Now let me write down the equation of normal. Which is y minus y naught, which is 4, equals to negative reciprocal of this is 4 into x minus 4. X naught is also 4. Now let me convert into y equals to mx plus c form. So y would be equals to 4x. 4 times 4 is 16 and positive 4. So y would be equals to 4x minus 12. Now for part B, find the coordinates of the stationary point. So for stationary point, we have to put the first derivative, the gradient would be equals to 0, right? So we have the gradient 3 over square root of 3x plus 4 minus 1 equals to 0. So we have to put it equals to 1. Cross multiplication, 3 would be equals to square root of 3x plus 4. So we need to do the squaring on both sides. 3 square is 9. This is 3x plus 4. So 9 minus 4, this would over 3 is the x value. So we have 9 minus 4 divided by 3 is 5 by 3. So x is 5 by 3. We need to find the coordinate, means x and the y both coordinates. Now put the x into the curve. So y would be equals to 2 square root of 3 times 5 over 3 plus 4 and minus x value is 5 by 3. Right. 3 is cancelled with 3. 5 plus 4 is 9. And square root of 9 is 3 and times by 2, which is 6, minus 5 by 3. 13 over 3 is the y value. So we can say that the coordinates of the stationary points, the xy coordinate are 5 over 3 and negative 13 over 3. Sorry. Yes. Now for part C, determine the nature of the stationary point. For the nature of the stationary point, we have to find the second derivative, d2y over dx scale. We have the first derivative. For second derivative, we can do 3 and the power rule. As you can see, this is the first derivative. So we have to apply the power rule by shifting the power into the numerator, minus 1 by 2. So first we have minus 1 by 2. 3x plus 4 power minus 1 and times by 3. Right. So here we will get 3 times 3 is 9, minus 9 over 2, and minus 1 by 2 minus 1 is minus 3 by 2. So this is equals to 3x plus 4, 3 by 2. This is my second derivative. Now let me substitute the stationary point into the second derivative. If it is positive, we have a minimum point, and if it is negative, we have a maximum point, right? Now we have to find d2y over dx scale at x is equals to 5 by 3. This is the x coordinate of the stationary point. Minus 9 by 2 into 3 times 5 over 3 plus 4, its power is 3 by 2. Right. 3 is cancelled with 3. 5 plus 4 makes 9. and its power is 3 by 2 and times by 2. So we have 54, right? Minus 9 divides 54 is minus 1 by 6. Minus 1 by 6, so it is negative. It is less than 0. So when the second derivative at the stationary point is negative, so we can say that the nature of the stationary point is maximum. Right. Moving to part D, find the exact area of the region bounded by the curve, the x-axis, and the lines x equals to 0 and x is equals to 4. The exact area, right? So for area, we have to integrate it. We have the curve y is equals to 2 square root of 3x plus 4 and minus x. We have to find the exact area bounded by the curve, the x-axis, and the lines x equals to 0 to x equals to 4. So we can say that the area is integration between 0 to 4 of 2 times square root of 3x plus 4 minus x dx. Right. Okay, so 2 is outside. The power rule, 3x plus 4, 1 by 2 plus 1 over 1 by 2 plus 1 times 1 over the derivative is 3 minus x square by 2. Definite integral, we are not adding c, between 0 to 4, right? Okay, so we have 3x plus 4, 2 by 3, 1 by 2 plus 1 is 3 by 2. 3 by 2 divides 3 by 2 times by 1 over 3 minus x square over 2 between 0 to 4, right? Further simplification, we have 2 by 3 times the reciprocal of 3 by 2 is 2 by 3. 3x plus 4 power is 3 by 2 minus x square over 2 between 0 to 4. So 4 over 9, 3x plus 4, 3 by 2 minus x square over 2 between 0 to 4. Now let me substitute the limit. Area is equals to 4 over 9. We have 3 times 4 plus 4 power is 3 by 2 minus 4 square over 2. The upper limit. Subtract the lower limit is 4 over 9. 3 times 0 is 0. We have 4 power is 3 by 2 and minus 0 is just 0, right? Simplify this. We have 3 times 4 is 12 plus 4 makes 16. Its power is 3 by 2. 64 times by 4 divided by 9, which is 256 over 9. 4 square is 16 over 2 and minus 4 power 3 by 2 times by 4 divided by 9 is minus 32 over 9. Okay, now let me simplify. 256 divides 9, minus 16 divides 2, and minus 32 divides 9, which is 152 over 9 square units. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.